referring back now to AS1684 and our timber framing. So we're going to look at a general sort of wall structure here. It's an internal wall. In this case it may not be load bearing, so I haven't finished the ribbon plates yet, but we'll look at the general sort of general structure, and we'll just talk about those load points, and when we discuss load points as well. So first off, structure wise, everybody tell me what the bottom part there is. Bottom plate, okay. Studs work in between the studs, nogging, top plate, pretty good. Above us, seeing our roof trusses. Now within the truss we have a couple of components in itself. This being the bottom one, can everyone remember what the...
You've got cords.
Yeah.
Oh, you want to know what that is? The truss beam.
Truss beam. The truss beam. Internally, we call them the webs. Okay. So as you can see, it's all about transferring those loads along the bottom beam of the truss to be able to spread those load paths that we talked about. So when we talk again about the load paths again, and any loads, and we'll take for instance, say this truss is sitting on here now, that it's transferring down onto the bottom plate, is being spread across here. So at the end of the day, that load path coming through has to be transferred around and across the slab. When we look at the fact that these trusses are going to be spanning from here to here, where then would most of the external or the load of the roof be transferring to? External walls, that's correct. So underneath those external walls, what would we expect to be? Footings. Yeah. And then the engineers would discuss that. We're probably at too late a stage here to see the actual footings done, but that's exactly what they're there for, is to be able to transfer those through. Now a couple of other points along the way, we'll see on the top, on this section here, let's go back over here to a point. Plywood is here as bracing. Okay, now up above this doorway, what do we have in there?
Lintel.
A lintel, that's correct. So we see in the case of this, there's obviously load bearing up here, staking the extra plate up above it to take some load weight from a truss point. So we've got a double plate there where the truss will sit upon. This particular lintel now is transferring the load which way? Horizontally. You can see here where it's being picked up by the additional stud under that point there and transferring that back down again. So underneath that point here, on the bottom plate, again there would be footings or internal beams in the slab design done for that. So again, it's all about this load. Load coming onto here, because if it was transferring onto this, the sill plate, what would be happening? We get bone. If that's happening there, what's happening to our doors here? They're not opening, are they? Exactly. So the whole idea is you take that load path round and away from that. And we'll look in a sec at some more serious sort of uses of the coil frames in the case of this. So again, bracing, top plate, and we call this an additional one to take load bearing. It's a ribbon plate or double top plate, sills, and again section there. We've got the lintels are being put up to transfer the weight around that window, down through the jam studs into the external frame. So the whole thing about any design, any of the houses we see around us is all based on the same principle within our AS1684. Take the load weights, transfer it out to the external walls, bring it down through the external walls and into the footings around it. Pretty straightforward, simple structural design that's maintained. 2 stories or single stories, it's all the same. Now the whole time, if you remember before, if we're talking about our composite beams and our weight there, we're talking about the amount of weight on that, and we want to be able to take that weight better, then what do we do with the internal structures underneath of it? Put more of them? Yeah. We're closer together. That's right. So if we're talking about something with a concrete tile roof, the trusses up above it might be at 450 centres. When we come down to a metal roof where we're half the weight load, then the trusses can actually be up to 900, even 1200 in particular cases, depending on what support they've got underneath of it there. So that's quite significant. So although we might have a bit more cost structure with the actual cost of a Met Colorbond roof as opposed to roof tile. Our structural cost can be significantly higher because the whole structural load bearing reduces, quite significantly. It comes down to the amount of trusses and the spacings underneath, and underneath those trusses, which are going to be sitting over the top of a truss. An external stud formation. So there's a whole heap of studs are reduced in the actual external frames as well. So it's a bit of a cost factor in that. So it's not just taking that load, but it's been examined the cost required to maintain that load up as well.